Here is the next example. It's a three-phase Y-Y connected unbalanced load. So we're talking about unbalanced load is shown in below figure. Find the current passing through the neutral wire. Also we'll find power supplied with the source, active power, reactive power, and apparent power, as well as power factor of the source. Now the 208 volts, that's a line to line voltage. Okay, what will be the phase voltage? The phase voltage will be 208 over square root 3. At the same time, remember the phase angle between the line voltage and phase voltage. So if you remember, this is VA in star star connection, or VB VC in a star load. Okay, the line voltage leads phase voltage by 30 degrees. Okay, so this must be minus 30 degrees. Now in the previous videos I never considered this angle. Here I'm considering that angle because this is an unbalanced load. So when it become unbalanced load, the neutral current, to find the neutral current, definitely that angle is going to have some impact on our current magnitudes and phase angles. Actually not magnitudes, mostly phase angles. Okay, so that's the reason I need to consider that negative 30 degree angle. So this is 120 at an angle of negative 30. Okay, because the line voltage is 208 at an angle of 0. So this is VAB. Your VA is going to be lagging 30 degrees. So that's the reason we'll end up having negative 30 there. So 120 over 20 at an angle of 30 is nothing but 6 at an angle of negative 30. Okay, I'm going to convert that into polar format, rectangular format. This is in polar format. So when I convert that into rectangular format, 5.196 minus J, 3 ampere. Okay, that's our IA. IB, same thing. The relation, I mean, if I know VA equal to 120 at an angle of negative 30, what is V? So basically this is VAN. What is VBN? VBN must be 120 at an angle of minus 150 degrees. So I have to have 150 degrees. So IB equal to 120 at an angle of negative 150 over 20 at an angle of 90. So that is nothing but 6 at an angle of minus 150 minus 90, which is minus 240 degrees. When I convert this into rectangular format, so 6 at an angle of negative 240 is nothing but negative 3 plus 5.196 ampere. Now I have VAN, VBN. What is VCN? VCN must be 120 at an angle of minus 150 minus 120, which is nothing but 120 at an angle of minus 270 degrees. So 120 at an angle of minus 270 divided by 8 plus J6. So 120 at an angle of minus 270 divided by 8 plus J6 is nothing but 10 at an angle of 36.86. So which is 12 at an angle of minus 306.86 degrees. When I convert this into rectangular format, that value is 7.2 plus J, 9.6. Now the neutral current, I'm going to add them together. 5.196 minus J3 minus 3 plus J 5 point, I forgot to put the J, 5.196 plus 7.2 plus J 9.6. Now the total current equal to, so the current in the neutral is 15.08 at an angle of 51.46. I mean, you're going to see the magnitude, so the magnitude you're going to see is 15.08. Now I found the current in the neutral. Now I'm going to find the total power consumed by the load or power supplied with the source. Now let me find power A consumed by the load A. Since it is a pure resistive load, cos theta A equal to 1. For a pure resistive load, power factor is always unity. So there is no phase angle between IA and VA. You can see that VA is 120 at an angle of minus 30, IA is 6 at an angle of minus 30. So the phase angle between those two is 0. So PA equal to VI cos theta. Okay, so V is 120, I is 6, and cos theta is equal to 1. So the power consumed here is 720 watt. Okay. Now QA must be 0 because there is no reactance. Now PB, power consumed by load B, must be 0 because there is no resistance. So active power always consumed by the resistor. Now QB, for sure there will be some QB because of the reactance. That value is 120 times the current passing through it is 6 amperes and sine theta. So here sine theta B must be 1, because if you look at here, the phase angle between VBN and IBN, which is exactly 90 degrees. So sine theta B equal to 1. So we'll end up with this as 720 volt ampere reactive. Now we'll find PC. So power consumed by load C, which is V, which is 120 volts, I is 12 ampere, and then cos theta, what is the angle between these two, V and I? You see V is minus 270, I is at 36.86. No, 36.86 is basically that is the impedance. This is the I, minus 306. So basically you will end up with 36.86. So cos 36.86. This 36.86 is phase angle between VC, VCN and ICN. Now same thing, QC equal to 120 times 12 times sine 36.86. Now we'll find these two values. I have PC equal to 1152.15 watt, QC equal to 863 watt. So total power is PA plus PB plus PC. PA I have 720, PB I have 0, PC I have 1152.15. The total is 1872.15 watt. Now Q total is QA is 0, QB is 720 and QC is 863. What kind of load is QC? So this is inductive load, this is also inductive load, so for sure both of them are consuming reactive power. So 720 plus 863, the total is, so I found the P total as 1872.15, Q total as 1583. So S total is nothing but 1872.15 plus J 1583. The units for this is volt ampere. For S is volt ampere. This is complex power. The apparent power is PT square plus QT square. That value is 2451.7 volt ampere. Okay. Now cos theta S is P total, which is 1872.15 over S total 2451.7. The power factor is 0.763 lagging. This is the power factor. Okay, this is a unbalanced load. So whenever we have unbalanced load, make sure you include the phase angles. In balanced load, you can include the phase angles, but without phase angles also we'll end up having the same answers. The only issue with the unbalanced load is neutral current is going to be different, because the phase angle is going to um, contribute some, I mean, the real part and imaginary part is going to be different. I'll stop this video here. I'll continue. I think I'm done with this chapter, with this video, but I might post more practice examples. Thank you.